The wind blowing from the Yellow Sea doesn't encounter residential buildings, nor container cranes. It crosses an almost hypnotic border of metallic cylinders, perfectly aligned, reflecting the gray sky of the Chinese east coast. At first glance, they are silent, more than one would expect for such grandeur. There are no visible flames, no refinery releasing steam, no drilling towers. But still, there lies one of the most strategic points of contemporary China's energy infrastructure. In the port area of Danzhongkou, in Qingdao, more than 50 giant tanks have been built in a row, forming the largest single crude oil storage unit among China's coastal ports. The project, estimated at approximately $700 million, has 5.2 million cubic meters of static capacity already completed, the result of 3 consecutive phases of construction. But these numbers don't fully explain the ambition of the project. Here, we're not just talking about storage, we're talking about strategy. Stay with us for the next few minutes and find out why. China has decided to turn steel, concrete, and heavy engineering into one of its quietest weapons of economic power. The Danzhongkou Commercial Crude Oil Reserve Base is located in Qingdao, in Shandong Province, one of the most industrialized regions in China. It is also one of the country's main energy gateways. Strategically positioned on the east coast, the base is part of the complex managed by the Shandong Port Group. This state-owned conglomerate, through its network of ports, accounts for about a quarter of China's crude oil imports, according to Reuters. Over 3 consecutive phases of expansion, the built capacity reached 5.2 million cubic meters of static storage. However, when we consider the connection with specialized piers, long-distance pipelines, and integrated terminals, the projected annual handling capacity exceeds 11.06 million cubic meters. In other words, these are not isolated tanks scattered along the quay, but an interconnected logistics system capable of receiving and distributing oil with high operational efficiency. And this is exactly where the central issue arises. After all, if Danzhongkou already had significant infrastructure since the mid-2000s, why did China decide to expand it in 3 phases and raise the complex to such a monumental scale? To answer the question from the previous segment, we need to go back a few years. In 2016, according to a Reuters report, a 1.2 million cubic meter facility backed by Mercury was inaugurated in Zhongkou. At that time, China had started granting oil import licenses to independent refineries, many of which were concentrated precisely in Shandong Province. The result was immediate. The flow of imported oil increased drastically, putting pressure on port capacity and causing tanker ship congestion. The existing infrastructure could no longer keep up with the pace of the new commercial dynamics. Faced with this scenario, the provincial government and the Shandong Board Group decided to take structured action. The project was divided into 3 clear and progressive phases. Phase 1 includes 16 tanks of 100,000 cubic meters each, as well as auxiliary facilities. Phase 2 includes phase. It added 24 identical tanks, significantly increasing the capacity. Phase 3, completed in 2023, added 12 additional tanks and critical safety structures, bringing the total to 52 large tanks. The total investment exceeded 4.9 billion yuan, which is about $700 million, almost 3.6 billion Rs at the exchange rate at the time this video was made. But maybe the most relevant fact is another one. Since the first 2 phases went into operation, the complex has already handled almost 80 million tons of oil in total throughput. This reveals a fundamental characteristic of the project. It's not about idle tanks, it's about strategic stock with high turnover. And now, an inevitable question arises. How do you safely and efficiently build infrastructure capable of storing millions of cubic meters of a flammable product right in the middle of an industrial coastal zone? The 3 phases of the Danzhongkou crude oil commercial reserve base have already been completed and are in operation, considering the complex as the largest individual coastal storage unit in China. On the outside, the project looks simple, dozens of metal cylinders lined up. But inside, an engineering mechanism that combines geotechnics, tank construction, industrial safety, automation, and port integration, all designed to turn oil into logistical predictability. The heart of the system is 52 tanks of 1,000 cubic meters, equipped with floating roofs. Instead of maintaining a large vapor chamber above the liquid, the roof follows the oil level, reducing the vapor space. In practice, this reduces evaporation losses and helps control emissions of volatile organic compounds on a large scale. This technical decision turns into money, with fewer invisible losses over the years and a cleaner terminal to operate. But before the steel, there's a tougher challenge: the coastal soil. Ports are usually built on compressible sedimentary layers, where settlements can slowly develop and become a structural threat. That's why the base of each tank requires geotechnical stability, controlled compaction, and deep drainage. The load is colossal depending on the density of the crude. A full tank can represent something between 80 to 90,000 tons. The construction advanced in 3 phases. In phase 1, 16 tanks were built, along with the process pump house, substation, and the first automation systems. This core allowed Danzhongkou to start operating with more autonomy. In other words, to receive oil without depending on perfect unloading windows and without being held hostage by immediate bottlenecks in gas. Next, phase 2 added 24 identical tanks, increasing the capacity by more than 2.4 million cubic meters. This expansion was not just about more volume. It required expanding the terminal's invisible muscle, internal pipelines, electrical power, instrumentation redundancies, and above all, the firefighting infrastructure. The logic is simple. Increasing storage capacity without expanding transfer creates a stock that doesn't move at the pace of the supply chain. Phase 3, completed in 2023, added 12 tanks and critical safety structures, including a pump house dedicated to firefighting and technical rooms for equipment. It's worth noting that in a facility of this size, the firefighting system is just as important as the tank. Pressurized networks, high-flow pumps, and foam systems are designed for immediate response, and redundancy is not a luxury. If one system fails, another takes over, preventing a local fire from turning into a regional energy bottleneck. Another important point: the visible tank is just a fraction of the investment. Around the tank, there is an invisible infrastructure: level sensors, pressure monitoring, relief valves, grounding against lightning strikes, automated control. None of this would make sense without logistical integration. The tanks are connected to the bodies, 4 superwells at the port of Danzhongkou, capable of receiving large oil tankers. The unloading goes through underground pipelines for storage or for immediate transfer to long-distance pipelines, which supply refineries in the interior of Shandong. This connection from the berth to the tank and from the tank to the pipeline turns time into money, reduces ship waiting times and docking costs, increases predictability, and speeds up the terminal's turnover. It's not a static storage facility, it's a redistribution hub. That's why Danzhongkou works as a strategic buffer between the international market and the regional refining complex. When there are favorable price windows, you buy in volume and store it. In the end, the project is not just about physical capacity. It's an infrastructure that combines structural engineering, industrial safety, and logistical intelligence. To increase resilience, reduce bottlenecks, and sustain economic stability, this reconfigures national decisions. To understand the magnitude of the Danzhongkou base, it's necessary to turn technical numbers into concrete references. The volume held at the base is equivalent to about 32.7 million barrels, which is almost 3 days of China's average daily imports. In clear terms, a single complex is capable of storing the equivalent of almost 72 hours of energy flow, which supplies the second largest economy on the planet. Such storage capacity is greater than that of many Brazilian coastal terminals. If we make a physical analogy, it would be more than 2,000 Olympic-sized swimming pools with tanks filled with crude oil. Visually, it's like stacking a small liquid city inside an industrial belt. From a financial point of view, an investment of more than 4.9 billion yuan would allow you to buy approximately 48,000 popular cars or finance the construction of several large hospitals. And all of this is applied exclusively to storage infrastructure. Danzhongkou stands out not only for its absolute volume, but also for the concentration of capacity in a single coastal unit, directly integrated with the port. And it is precisely this compact integration between berth, tank, and pipeline that turns Danzhongkou into more than just a depot, into a strategic instrument on a national scale. With all three phases completed, Danzhongkou is consolidated as a strategic part of China's energy matrix, not only because of the amount of oil it can store, but also because of its ability to turn storage into predictability. In other words, a base of this size reduces the exposure of Shandong's refineries and industrial chains to abrupt fluctuations in international trade, creating a buffer zone between the price out there and the need here inside. In addition, integration with maritime routes, superberths, and pipelines increases regional logistical competitiveness. The oil arrives, is unloaded efficiently, can be stored safely, and is quickly redistributed inland, reducing port bottlenecks and ship waiting costs. In a global scenario marked by energy volatility, storage infrastructure is no longer just operational support, but becomes an instrument of economic security. And the future of the project appears precisely in this post-construction phase. According to China Daily, with all three phases in operation, the projected annual storage capacity and annual turnover of the complex exceed 11.06 billion cubic meters per year. In other words, it's not just the static volume of the tanks, it's how much the system can receive, store, and rotate throughout the year. More than 50 giant tanks. They may seem excessive at first glance, however, when viewed from the perspective of energy security, integrated logistics, and commercial strategy. They become part of a precise calculation. Danzhongkou is not just an oil depot, it's a system that connects import, storage, and distribution with industrial efficiency. And in the contemporary global scenario, whoever controls this transition between the ship and the refinery controls much more than infrastructure. They control economic stability. Thanks for watching until the end. What do you think of this impressive Chinese construction? Looking at it from a geopolitical perspective, is China, with its large-scale infrastructure capability, preparing to dominate the world's energy scene? Or is it just a matter of time before the United States reverses this scenario? Leave your opinion in the comments. I'll stop here, a big hug, and see you in the next video.